Okay. Hi guys. So welcome to my channel. If you would like to know more about me, you can probably watch the introductory video. But right now, let's not waste any time and start doing question. So the first question that I'm going to pick up is an LC-70 easy climbing stairs. Okay. So yeah, let's read down the question and try to attempt it. So the question says, you are climbing a staircase and it takes n steps to reach to the top. Each time you can either climb one or two steps. In how many distinct ways can you climb to the top? So it means that there are n steps or stairs, and each time when I'm taking a step, either I can take, climb one step or I can take two steps at a time. So if I have to reach the n steps, in how many different ways can I reach that step? So if I have to look at some examples on how this would be done, so let's try to run through some examples. So let's say my n is equals to 3, which means that I can either take 1 comma 1 comma 1 step, or I can take 1 comma 2 step, or I can take 2 comma 1 step, right? So the answer in this case would be 3, because I can take 3 different ways to reach to the top stair, right? If let's say my n is equals to 2, so what can I do? I can do 1 comma 1, or I can do 2. That is the only option I have, right? So in this case my answer is 2. Let's say n is equals to 4. So what would be the different number of ways to reach the fourth step? One could be simply take like one step like this, 1 1 1 each time. Another could be 1 comma 2, or let's try it from 1 comma 1 comma 2, or 1 comma 2 comma 1, or um, 2 comma 1 comma 1, right? 3 and 4, or it can be 2 comma 2, right? So in this case 1 2 3 4 5, my answer is 5. Okay. So if you think about it, actually, this is a recursive problem, because every time you're taking some step, what is the possible outcomes depends on what you took before it. So let's say I have to reach the third step, but in how many different ways have you reached the second step? Based on that, whatever is the possible option for you, you'll take the next step, and then all of these will add up to finally reach the third step. So the recurrence for this one would be f of n minus 1, because I can take one or two steps, right? Plus f of n minus 2. You can even uh, sort of try to verify this by saying that, let's say my n is equals to 4, right? F of 4, f of 4. This would be equal to f of 4 minus 1, that is 3, plus f of 4 minus 2, which is 2. So f of 3 and f of 2, what is that? F of 3 and f of 2 is 3 plus 2, 5, which is actually the answer for n equal to 4, right? So in this way you can, dry run your recurrence to get to know like if you're thinking in the right direction. Now let's not waste any further time and try to get into the code part of this. So um, let's first try to think of the base case for this one, right? So what would be the base case, do you think? If let's say I have just one step to be taken, do I need anything to do? No, right? I can simply return. Similarly, if I have two steps to take, do I need to do anything? I already know the answer. I don't want to do any further computations. 2 means the answer is 2, either 1 1 or 2, right? So that means my base case can be written as something like this: if n is equals to 1, or n is equals to 2, you can simply return n value. Okay. What would be my recursive step? It would be return climb stairs, right? N minus 1, plus, oh man, climb stairs n minus 2. Okay, this would be like a simple naive solution for this. Now, time complexity of this would be exponential. Why? Because you are going through all the possible solutions. So, and there are two different calls that you are making. So it is 2 to the power n. And let's try to run it to see how it is going. Okay, let's try to submit it. Let's see what it does. So basically, what you're saying is that it gives time limit exceeded, 31 of 45 test cases passed, which means that the remaining test cases are for a greater value for which this solution is not optimal. It is taking a lot of time. Now let's try to optimize it. Now, actually, if you have to optimize it, you can actually think of it as how Fibonacci works. This is basically a Fibonacci question only. Uh, so the way that you optimize a Fibonacci problem, right? How do you do it? You use a DP solution and you sort of store your previous computation so that you can directly use them instead of computing it again and again, right? That's what we are going to do in this question. So let me make a, let me just copy it only. Copy it and let's name this one as climb stairs 1 and one more copy we'll need. This would be my DP solution, which I'll call, and this would be the original solution submitted to me. So what I'll do is I'll just call it from here. So first of all, what do I need? First of all, I need a DP array, right? So I make a DP array of int n plus 1. Okay. And what I'm doing is I want to initialize that array because I want a way to know whether this computation was done or not. Now, what can never be the answer? It will be a negative number, right? So I'll just initialize my DP array with -1. Cool. Now I'll pass it in the parameter and the name of this is DP. Let's now actually do it in the code. This is how the parameters defined. The base case remains same, right? What else I need to add it here? Basically, what I need to do is I need to check that whether that computation was earlier done or not. If it was done, that means it is not -1 now. So you don't do and go further and compute it again, right? You simply return it. So what you do is return dp of n. Okay. Else, what you do? You first of all correct the names of these functions and you pass the dp array to both of them and you store the calculation also, right? Because every time you're making a calculation, you're making a call to n minus 1 and n minus 2, whatever the answer is it is returning, you have to store it somewhere, right? So that you can use it in your further computation. So that is why this statement. Now let us try to run this one. Yeah, let's see. Now it's saying wrong answer. Why? Did I miss out on something? Test result output is 1, expected is 3. Climb n minus 1 and minus 2. If, oh, sorry. I think I called it again wrongly. Let's run it now. Okay. Yeah. Sorry for that. So basically, yeah. So this is your basic test case. Let's try submitting it if your TLE goes away or not. Let's see that. Okay. So yeah. So it got accepted and it also beats like 100% of the users in Java. So which is good, right? So basically, just like a little recap, we start from this naive solution. We just introduce a DP array. Very simple. And you simply store that value in whatever your DP array is. And most importantly, you use that. So you don't have to go and make another recursive call. You can simply return from here. That's how this works. So yeah, that was all for this video. Thanks for watching. Bye bye.